Hello everyone! Today we'll talk about the solution to the problem course schedule 4. This is quite a straightforward directed graph problem, which is useful for you to practice your implementation skills, since the intended solution is essentially just a brute force. Maybe not a completely dumb brute force, but even a pretty dumb brute force would be okay, since we have a list of queries that specify the starting node and the ending node, and we just have to say if there is a path from the starting node to the ending node in our original directed graph. Or in other words, if we create a transitive closure of the original graph, then we want to see if there is an edge from u to v, if the query is uv. And the two approaches that are straightforward is either to, for every query, run a DFS or a BFS over the whole graph, so just try to reach v. So that would be one brute force solution. And another would be to construct the transitive closure explicitly, and then just check the edge in the transitive closure. And I'm going to show the second option. And when it comes to creating this transitive closure, there are again multiple approaches you can try and do. You can do some relaxation-based approaches, where you try to shorten paths step by step, and you notice that the two nodes can only be as far from each other as essentially the number of nodes. So there is a bounded number of steps where you for sure will not improve anything, sort of in a Bellman-Ford fashion. But simpler in implementation and simpler conceptually idea is just to use the Floyd-Warshall algorithm. The idea of the algorithm, if you're not familiar, is that you can just go over all the nodes, so all the nodes I and j, and try to see if I and j are connected via a single intermediary node, which will be the node k. So to see if I and j are connected via this node k, we check if we can get from I to k, and check if we can get from k to j. And now if we go over all the nodes, with the outside iteration being over this intermediary node, this is important for the correctness of the algorithm. So essentially for every intermediate node, and for every node start and end, we try to reach end from start by just stepping into that intermediate node. So in essence, we'll be creating a matrix, a two-dimensional n by n array that will tell us if we can get from u to v at the crossing of a given row and column. So at first we can't reach anything other than what we know from the prerequisites. So if we have uv in prerequisites, then we mark that we can get from u to v. And now running the Floyd-Warshall algorithm, the algorithm for which the complexity analysis is one of the simplest analyses possible, because it's literally just a single line within a triple nested for loop, and all of those for loops are over n. So this is just a very straightforward n cubed algorithm. So we go through all the intermediary nodes, and we update the value, and the value is, of course, we OR it with the end of those two. So if both of those are true, then this is true. And if this was true already, then it's still true. So that's why we OR equal it. Other ways of writing it, of course, exist. This is a pretty short and straightforward way. If you're not used to using those binary operations, logical operations, then make sure that you understand it, because it's very basic. And of course, at the end, now in math, we have the adjacency matrix for the transitive closure of the original directed graph. So we can check for u and v in queries if that edge is true or false, if it exists or not. And that is the whole solution.